Hey, yo, 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 Algebrainiacs. Here we go. It's the Johnson Kendro Video Hour.
But it's not an hour.
Ours is a fun time, though. Okay, 11.2 probability. What's the probability? It means the likelihood that an event will or will not occur can be written as a decimal, a fraction, or a percent. Now, there are two types. We have experimental, and look at the root word in that word.
Experiment.
Experiment. It means you actually do an experiment and see how it comes out. So, a number of times the event occurred over the number of times that you do the trial.
Could you use like somebody else's experiment to?
Oh, yeah,
Okay.
sure.
We don't have to run them all.
No, we can read about experiments.
Okay.
And then theoretical means in theory, this is what should happen. So it's favorable over the number of trials. So favorable over total. All right, let's try it. Example of flipping a coin. Find the theoretical means what should happen every time you flip a coin. Well, how many tails are there on a coin?
One.
One out of how many sides?
Two.
So theoretically, a tail should happen 50% of the time, or one out of two times. Now, we have a fancy dancy little coin flipper here, so we're actually going to try it and see what our experiment happens. All right, so heads and tails. So, all right, I'm going to say start and stop, and Miss Johnson's going to do it. Ready, go. Start.
Oh, shoot.
Oh, we got to put that down.
Now I gotta delete my dot. Okay.
Start. Oh, flip and stop. All right, tail. Start. Stop. Ooh, another tail. Start. Stop. Ooh, another tail.
Tails
Start.
never fail.
Stop. Ooh, okay. Start. Stop. Oh my goodness. It's getting closer to 50%. And stop. Oh, there it is, 50%. Start. Stop. Heads is coming out in the head. Stop. Oh my. Start and stop. Goodness gracious. Could it be? Ready? Stop. Oh, heads. Okay, so it didn't come out quite 50%. So tails was only 4 out of 10, which is 40%. So experimentally, it didn't come out to its theoretical, and they don't always match. But I bet if we did this a lot more times, it would come out to be closer to 50%.
Isn't that called something in math? A
Yeah,
law?
law of large numbers,
Yeah,
I believe.
that's right.
It's a really fancy name.
So what that means is the more times you run an experiment, the closer it will be to the theoretical probability.
Right, very good. All right, next. Venn diagrams. Mr. Venn came up with this. I wonder if his first name was Sven. That'd be tough. Sven Venn. All right.
I went to school, my locker was next to John Johnson.
Oh, and you are a Johnson.
Yeah, right.
That's
our
probably why
lockers
you're
are
next to
each
it.
other.
Very cool. Okay. A Venn diagram is a way to organize the information, just to make it
Really helpful.
Yes, so use it and you will be happy. All right, Spring Lake High School, 100 students are surveyed at random. So our sample space is 100 kids. Of those, 40 are taking Spanish. Okay, so we'll make a circle for Spanish. 35 or 50 are taking English, and 35 are taking both. Now, because they're taking both, we have to overlap them. So we're going to make the two circles overlap. So the left side is just Spanish, the right side is English. The middle, where they overlap, is both. So we're going to be happy. We're going to fill in the numbers now. All right, the first part you should fill in is the middle. So 35 are taking both. Okay, now.
So I fill in 50 on this side.
No. It has to be a total of 50. We already have 35 in the blue circle. So how many more do you need to make 50?
Oh, I see. So 15 of the kids are in here.
Right, because 35 and 15 is a total of 50.
They're in the just English part.
Right.
Okay.
Okay, what about Spanish? I need 40 total. Right, so 5 and 35 gives me a total of 40. All right, let's answer some questions. Oh, one thing before we do the questions is how many are not taking either Spanish or English? I have 100 kids, but how many total are taking Spanish and or English?
5 and 35
40,
40, 55.
55.
That
So
leaves 45.
are not taking a language.
They're in the sample space.
They must be taking math.
Yeah.
Lots of math.
Oh, yeah.
Okay, what's the probability that a kid is taking English?
Is it 15?
Well, are only 15 kids taking English?
No, it's everybody in this bubble.
So there's 50 kids taking English out of those 100. So 50%. Okay. Next, how many are taking Spanish and English?
That's just our little overlap.
Right, because they have to be taking both. So 35 out of 100. I'm glad you picked 100 to make our percents
I
easy.
do it on purpose.
Ah, you so smart. Okay, number 3 is not English. So that means they're not taking English or any other language. So, how many are not taking English? Just 5. They're taking Spanish, but how many are not taking either language? So 50.
Wait a second, I noticed something.
I see another 50 on there. Somewhere.
Right. Okay. So we are talking in number 1 about kids that are in English. And here we are talking about kids that are not in English. And if we added those two things together,
They should be all of the kids.
yeah, that's called, they're called complements.
I see. They complement each other because...
They're mutually exclusive events. We're going to get that in the next video.
That sounds like a fancy word.
So anyway, what I was going to say, you could have just done 100% minus your 50% from your number 1.
From those who are. The
Right.
rest have to be those who are not.
Be tricky.
Yep. All right, number 4. Let's see. All right, what's the probability of Spanish or English?
That's everybody in the bubbles at all.
Right, because that lists everybody. So that's 55. See, we could do the same thing for that one as we did the previous one, because there's 45 not taking either, so that means 55 have to be taking something.
Right.
Or one or the other.
Cool.
All right. Okay.
Geometry? I thought this was algebra.
But it's probability.
All right, so we're going to use the area of an object to calculate the probability. You'll do a couple problems that are circles, and you will also do some that are rectangles. We're going to do circles so you get some more practice with that formula. So we want to find out what is the probability of scoring 5 points. And this is our beautiful dartboard. And where she's coloring there, that's the area that we are considering success. And there's some information below. It says that the radius of the inner circle is 2 inches, and then the width of each ring increases by 2 inches. So that's going to help us with some measurements. So how do we find, for geometric probability, we're doing the area of the desired spot over the whole area.
Okay.
So the desired spot, how do you find an area of a ring?
Well, you have a couple circles that we could take part of the interior section away, and that will leave the ring.
Okay, so we want to find the area of like the whole outside white circle.
That would be, I could see about that.
Okay, and then we will remove, starting from the blue in.
So we're going to remove that whole piece.
Okay, so we got to find some radii. What is the radius of the outer white circle? It's 2 inches for each ring, and then don't forget the inside is also a radius of 2 inches. So 2, 4, 6, 8! Who do we appreciate? Algebra 2! Algebra 2!
Mr. Pythagoras. That's who I appreciate.
All right,
So our radius is 8.
for the big one.
Big circle. So let's figure out the area of that.
So we use the formula pi r squared. So that will be pi times 8 squared, which is 64 pi. You mean I don't have to do the button? The pi button?
No.
Okay, hold off on that.
Hold off.
Something
Yep.
special is going to happen. All right, and then we need to remove the part that is X'd out in black. Now it's in green.
2,
4, 6. squared is 36 pi. Okay, so if we subtract those two, that will tell us the area of the little ring. So 64 minus 36 is 28 pies.
Yay.
Okay, now hold on a second. Probability is supposed to be a fraction or a decimal or percent. It's supposed to be the desired over the total.
Okay.
So we just found the area of the desired. We need to divide it by the area of the total. So that is going to be the whole dartboard. So we got to add another ring on there, the outside red ring. Red ring.
Red ring. So we add another 2.
So 2, 4, 6, 8, 10.
So r is 10. Then we have r
Pi, yeah.
squared times pi, so 100 pi.
That's the outside. And look, I picked 100 again.
You are awesome. So here's where the pi's cancel.
Oh, okay.
And 28 over 100 would be 28%.
8%. So that would be if we were blindfolded and we're just checking it.
All right, but we're better than that.
Right.
At darts.
All right, let's do another one. This one says probability of scoring at least 10 points. So let's get rid of our drawing so we can draw again. At least 10. So 10 is the blue ring. And then 15 is higher than that. That's inside of that. And then 20 is inside of that too.
So we want all of this.
Right.
Over the total. Now we still remember our total is 100.
So we can reuse that.
Right.
Okay, so 100 pi is going to be on the bottom. But now we don't have to do any subtraction.
Oh.
We're just going to do 2, 4, 6.
So we already did 6 earlier.
So
we
it's
have
36 pi.
Over the total.
36%! I'm so good at dividing.
Yay.
All right, cool. Hey, just so we remember, how do I find the area of a rectangle? We got to do a batter's box in the homework assignment.
Oh, rectangles. Let's see. Length times width.
Oh, okay. So if this were 2 and 4.
8.
Yeah, square whatevers.
Yep.
Cool.
All right. Ta-ta for now.
Bye-bye.